Let's get to the lab here now on the back of the goldenrod sheet. The unknown in the lab was something that you may have smelled before. Usually guys, fellas, have a little bit more knowledge of these, but anybody that uses a porta potty has probably smelled this before. It's also in urinal cakes. It is called p-dichlorobenzene. And no, the P doesn't stand for pee, even though it is kind of funny. But that is the substance that you used in the lab. Would doubling the amount of the p-dichlorobenzene in the test tube change the melting or freezing points? If it changes the melting or freezing points, that means that melting and freezing points would be extensive properties, a property that's dependent on the amount of material that you are using. But the freezing point and melting points don't change. Okay, it doesn't matter if you have a glass of water or if you have a whole lake of water. That water freezes at 32 degrees Fahrenheit. We already know that. Well, the same is true for every other substance. The answer to this question is no. The reason why it's no is because melting point and freezing point are intensive properties. They do not depend on the amount of matter. The one thing you do notice is that if you are freezing a glass of water compared to a lake, the glass of water will freeze a lot quicker. Well, that's because there's less water there, so the amount of time it takes to cool down that amount of water is less. The time is less, not the freezing point or melting point itself. Next, we have a couple questions about this curve that is on the back of your goldenrod sheet. This shows a solid being heated up all the way through the melting point and then the boiling point. So we have all three states of matter here. This first upward part of the graph is when the substance is a solid. Then this plateau represents melting or freezing. And then we have another upward section. This represents when the substance is a liquid. And then we have another plateau, which is represented by the boiling point or the condensation point. And then we have the formation of the gas. The thing we need to realize here is that temperature is a measure of kinetic energy. That's what temperature is. Temperature is directly related to kinetic energy. The more kinetic energy a substance has, the higher the temperature of that substance will be. If that's the case, then these two questions become a little easier. The diagonal parts of the graph, so that's these parts right here represented by solid, liquid, and gas. During those parts of the graph, the temperature is changing. That's why they have an upward slope. If the temperature is changing, then the kinetic energy is changing because temperature and kinetic energy are directly related. The molecules are moving around a little faster, which means they have more kinetic energy, and since temperature is a measure of kinetic energy, the temperature increases. During these same parts of the graph, the substance remains a solid, or a liquid, or a gas. So the potential energy of those substances is constant during those periods of warming up or cooling down. Now the horizontal sections, or the plateaus, represent phase changes, and during a phase change the temperature is constant. That means the kinetic energy is constant. If the temperature is not changing, that means the molecules are not moving around any faster or any slower, so the temperature remains constant. However, there is a change of state going on, and if a substance is turning from, for example, a solid into a liquid, then its potential energy is changing. So at the horizontal plateaus, the kinetic energy is constant, but the potential energy of the substance is changing. All right, a couple new terms for you. Exothermic and endothermic. Thermic means heat. The prefix exo means exit. The prefix endo means enter. So there are 3 exothermic phase changes and 3 endothermic phase changes. If a phase change is exothermic, that means the energy is being released. The energy is a product. So if you flip back to the front of the sheet we're taking notes on here, you can look at the phase changes here. Whichever phase changes have energy as a product on the right-hand side of the arrow, those phase changes are exothermic. Endothermic means energy needs to be put in for that phase change to occur. Once again, if you look on the front, there'll be 3 phase changes that are endothermic. So why don't you take the time to fill in which phase changes are exothermic and which phase changes are endothermic. So when we look on the front, we can see that freezing, condensation, and deposition are all exothermic processes. Energy is released, it exits. Okay. The three endothermic processes are melting, boiling, and sublimation. Energy has to put in to get those phase changes to occur. Finally, hopefully this question isn't too mind-blowing. In what phase of matter does the substance have the highest kinetic energy? Well, if you look on the graph, the gas phase of any substance will occur at the highest temperature, therefore it has the highest kinetic energy. And we'll just finish here with another little demonstration. I'm going to light a match with water. That sounds pretty cool. So let's see how that happens. In order to light a match with water, you'll have to get the water hot enough to ignite the match. The only way to do that is to turn the water into steam. So you can see here I'm boiling the water in the flask, and the steam that's being produced is passed through this coiled up copper tubing. The steam would be at a temperature of 100 degrees Celsius or 212 degrees Fahrenheit. That's not hot enough to light a match, but we can continue to heat the gas with a propane torch here. So that's what I'm going to do here. I'm heating the copper coils with the propane torch, and I'm raising the temperature of that water vapor. And as soon as the temperature gets high enough, it will be able to ignite the match. And then, of course, just for fun, let's do some flash paper as well, because fire is always entertaining.